Imagine on the surface of a balloon, you have dots painted. Next to each dot is another dot. Next to this dot is a dot over here, and so on. Imagine the space between dots is, let's say, 1 inch. So let's say we have 3 dots, this one, and that one near each other. This is 1 inch, and this is 1 inch. And now you blow up the balloon is expanding. Over a period of 1 second, the balloon doubles, and instead of 1 inch is 2 inches, instead of 1 inch is 2 inches. So how far have these moved apart in that 1 second? Well, they were 1 inch apart, now they're 2 inches apart. So they moved 1 inch in that 1 second. How far have these moved? They've also moved 1 inch in 1 second. How far have these two moved from each other? Before, there was 1 inch plus 1 inch. Now there's 2 inches plus 2 inches. So before there was 2 inches between them, now there's 4 inches between them. So although the neighboring dots will move 1 inch in that 1 second, the ones that are the next neighbors will have moved 2 inches in a second. And you can see by the same logic that the ones twice or 3 times removed will have moved 3 inches in a second. In other words, if you were standing on this balloon and looking at the dots, you would see all the dots near you receding from you with increasing speed the further away the dots were. The closer dots would be moving at 1 inch per second, the further dots would be moving at 2 inches per second, the further dots would be moving at 3 inches per second. And this is an allegorical model to the space of the universe. The universe is 3-dimensional in space, but if the space in between the galaxies is increasing, according to this theory, then one should observe the same kind of pattern. Wherever one would stand in the universe, in whatever galaxy, one should see all the neighboring galaxies moving away. And the further the galaxies would be from you, the faster they should be moving. Clearly, as it expands, the dots are going to separate from each other. Right? Now, imagine neighboring dots, okay? And let's say the distance between closest neighbors is 1 unit of distance, okay? So here's 1, here's 1, this is 1. They're all separated by 1. It can't, of course, be triangle, all of that, but something like 1 for each of them. Now, over a period of time, it expands until this is twice as large. This distance is twice as large. So they're all receding from each other. You can see that they're all getting away from each other. And now it became 2 units. What will be seen if you stand over here? What will you see? What pattern will you see? And will it be the same pattern that you would see from here, or how would it look? Anybody tell me? If you're standing here and you're looking at these dots, what will you see? Will it look bigger? Okay, very good. If the dots themselves expand, then the dots will look bigger. Okay, what else will you see? They'll be moving away from you. Right? If the distance is increasing from 1 to 2, then that means that all the dots are moving away from you. Right? Now, will that look any different from here, or from here, or from here? No, because there's no difference between any of the dots. So basically, wherever you stand, what will it look like? It'll look like all the other dots are running away from you. Right? But that will be a view that everyone has. Now, what modern cosmology assumes is 2 maybe strange things. One, that the distance between here is increasing without this size getting bigger. So these dots are our galaxies, or clusters of galaxies, and the galaxies themselves are not getting larger, but the space between the galaxies is. And that's a little conundrum that one could resolve, but it would take a little bit longer to explain that. But basically, this pattern that you would see everywhere, the same is an assumption. We don't know if what we see from our galaxy really is the same as it would be viewed from another galaxy. We would have to go there and see it. The assumption in modern cosmology is that everywhere in the universe is the same. Whatever we would view here, you would view elsewhere. And therefore, if we would see this pattern of everybody moving away from us, everywhere else would also observe this pattern of everyone moving away from us. Now, in a given instant of time, let's say in 1 second, as this doubled from 1 to 2, this is a 1 to 2. All right? What speed will this have been moving away from us? If it went, it was a distance 1, and then a second later, it was a distance 2. Okay, so it moved a distance of, how much distance did it move in that time? It moved the distance of 1, because it went from 1 to 2. In how much time? In 1 second. Okay? So it has like the speed of 1. Now, if you look at from here to this one, here, this one will be moving away at the speed of 1. Well, how far will this one be moving? How fast? Well, this one changed from 1 to 2, and this one changed from 1 to 2. So the total distance changed from 2 to 4, right? In the same amount of time. So it started out at a distance of 2, and each of the ones that made the 2 went to 2, so the total went to 4. So it went a total distance of 2 to a total distance of 4. So what is its speed? How much distance did it cover? It covered a distance of 2, and it went from 2 to 4 in the same amount of time. What does that mean? That the recession speed of the further one is twice as fast, twice as much as the recession speed of the closer one. And if you go to the next layer of dots, it'll be that much more. So the prediction would be, if the universe's space between the galaxies is expanding, one would observe that the galaxies are receding from us. And one would also observe that the more distant the galaxy, the faster would be the recession velocity. And that, in fact, has been observed. And that's what made Hubble famous. That's why the Hubble telescope is named after Hubble. The interesting thing is that Einstein's equations predict this, and we'll see a little bit about that. And the irony is that Einstein himself did not predict this, although his equations did, because he firmly believed that the universe is static. Let's imagine the galaxies, like little dots in this room, and I would say that space is expanding. What would that mean? What I mean by that is that not necessarily the galaxies are expanding, but somehow the space between the galaxies is getting more, so that each neighboring galaxy is getting further and further from the other. So that the distance between galaxies is expanding without them moving. They're not moving, it's just that the space between them is expanding. Now this again is a radical concept. If you try to come up with some kind of mathematical relationship, you'll see that, let's take neighboring dots. One dot, another dot, another dot, another dot. Okay, here's another one, another one, another one. Each dot is, let's say, a galaxy. If you take adjacent dots, let's say they're an inch apart. Okay, and let's say over the next second, as you're blowing up the balloon, they move from 1 inch to 2 inches. So the distance has increased by 1 inch in that second. So the speed that it's been moving basically is 1 inch per second. If you look at the next dot over, if this was 1 inch and this was 1 inch, and now this is 2 inches and this is 2 inches because each dot is separating, right? So this one was 2 inches away from this one. Now it's 4 inches away from this one. So again, you have these 3 dots, a 1 inch between them. Now there's 2 inches between them. So in terms of the distance from this one went from 1 inch to 2 inches. This one went from 2 inches to 4 inches in the same amount of time. So this one was moving away at 1 inch per second. This one was moving away at 2 inches per second. And if there was another one here that was initially 3 inches away, and now it's 6 inches away, so it went 3 inches in that second. So the closest neighbors move away at 1 inch per second, the next neighbors move away at 2 inches per second, and the next ones move away at 3 inches per second. And that's true for every single one. And it doesn't matter where you are. The one that you say is moving away from you at 2 inches per second or 3 inches per second, from their viewpoint, would see everything moving away from them at 1 inch per second, 2 inches per second, 3 inches per second. In other words, in an expanding universe, what one would expect to see would be all the galaxies in every direction moving away from us with larger and larger speeds corresponding to their distance from us. And this is a staggering projection to make onto the universe as a whole. And in fact, measurements were made, and this was found, in fact, to be the case.